Hi, today we want to introduce our final project for blockchain and Web3 applications, which is called Contract Guard. And our team member is Coulson, Lei, and Weiran. So first of all, in the digital age, the reliance on our contract continues to grow. So there are some challenges with their security, transparency, and efficiency. Today, we want to introduce our own solution to the pain points. The pain point is contract tampering. Traditional digital contracts is unauthorized modifications or disputes. And another point is the data vulnerability, which is storing contract data in centralized system exposes the sensitive information. And another point is the lack of transparency. Lack of transparency erodes the trust in contract and execution and modifications. And the next page is how we address the pain points. So the first of all is we want to have immutable contracts. The leverages of Web3 technology for tamper-proof immutable contracts. And we want to also secure data storage, which is provide decentralized blockchain storage that reduces data risks. And we only store hash contract. Another point is transparency and trust. We want to provide a transparent ledger, enhancing trust among parties.
Why use the Web3 for the contract guard? Because we want to leverage the following features of the Web3. The first thing is the trustless environment. Web3 and blockchain technique just provide us a trustless environment where the contract can be executed based on the predefined rule, which is very transparent without intermediary. This reduces the need for a trust between two parties. And the second thing is immutable ledgers. The blockchain's immutability ensures that once the contract is recorded, it cannot be changed and providing a secure and transparent audio trail.
Here is a short demo of our project. I'm going to introduce two main functionalities that we have. The first one is to upload the contract onto the blockchain. Let's say Alice and Bob, they signed on a contract in the real world, and they want to upload this onto the blockchain so that it cannot be modified and they can verify it later. So in order to do this on our website, they need to enter the metadata, which means their information, the address and the name. After we have filled in the metadata, there's a credit here. The credit here represents the level of importance of this contract. If they enter a big value, more gas fee will be applied when sending this transaction onto the blockchain so that this contract will be uploaded as soon as possible. Here, Alice and Bob is going to enter the content of their contract they just signed. Let's say Alice is going to pay Bob $10 in 5 days. And then click Add Contracts. Here, it will show the ID of the last contract they just uploaded. The ID is 1 here. We will use this ID when we verify this contract. So once Alice and Bob, they want to verify the contract, they can enter the ID of the contract they just uploaded and the content that they need to verify. So they will enter their contract content again to see whether someone has modified this contract. And it will show that the content is verified to be true, which means that the content they upload onto the blockchain is same as the one they entered here. But if Bob wants to change the contract, let's say change the day into 3 days. so that Alice will not agree. So they will come to this platform and verify that whether the contract is true or not. So the website will tell them this contract is inconsistent with the one they upload onto the blockchain.
Let's take a look at the visualization part of our contract guard project. We have been using the D3 library in the JavaScript to achieve this visualization. So here, this is an example of all the contract within our deployed network. Each node in this graph is represented by a unique user, and the line between two nodes represents that there is a contract between those two users. For example, now let's check the nodes called Columbia. There is a line between Columbia and our professor, Web3 students, and all the teammates and TA Sally. So you may notice that the line between the professor and the Columbia is thinner than the rest of the line. So we have designed this visualization part in the way that the thickness of the line is actually present the value of this credit. If someone believes that their contract is very important and they want to get confirmed as soon as possible, well, they may assign a higher credit to their contract. And showing in this data visualization, well, there will be a thinner line between two nodes. And one additional feature of our visualization part is that we added the fish eye effect on our the force directed graph. Because sometimes the contract can be really complicated, and if you want to see the small part, it could be difficult. So once the nodes are all settled down, you may want to take a good look at some part. You may just move your mouse, and the nodes, the line, the name will be amplified so that you can have a clear vision. Also, if you do not like the layout of the graph at the current stage, you may just click and drag the node to anywhere you like. So that's it. That's the visualization part.
Now let's look at what we can do in the future to make it better. First, we need to add the sanity check to the script. For example, to ensure that the addresses the user typed in is valid. Also to set limits on the size of the contract that the user is going to upload. Second, we probably need to consider adding more functionalities to our contract, but currently we don't have any better ideas. If anyone has a good idea, please let us know. Third, from the security level, we need to consider encryption for sensitive information in our contract. Then with regard to how do we make profit, we may charge a small amount of transaction fee every time the user upload the contract or verify the contract. After we got those fees, we may consider how to make use of them. Yeah, that's all about what we can do in the future, which brings us to the end of our presentation. Thanks for watching.